Hi, a very warm welcome to AIMS University, Malaysia. Today I am going to take you to the world of isomerism. This presentation will help you to gain the knowledge regarding isomers, isomerism, and types of isomerism. Let me start with what is an isomerism. Before that, let me tell you one thing. In nature, many things look similar, but in fact, they are completely different. This funny picture shows how things look similar, though they are completely different from each other. Now, let us see what is an isomerism. The compounds that have the same molecular formula but with different physical and chemical properties are called as isomers, and this phenomena is called as isomerism. Isomers do not necessarily share similar properties unless they also have the same functional groups. To explain in more detail, isomerization is a process by which one molecule is transformed into another molecule which has exactly the same atoms, but atoms are rearranged. In some molecules and under some conditions, isomerization occurs spontaneously. When isomerization occurs intramolecularly, it is considered as rearrangement reaction. Here, intramolecular means isomerization is taking place within the molecule. This will lead to rearrangement reaction. Coming to the history of isomerism, isomerism was first noticed in 1827 when Frederick Euler prepared cyanic acid, and he has noted that although its chemical composition was identical with fulminic acid, its properties were quite different. In 1828, Euler also discovered that urea and ammonium cyanide had the same atomic composition. In 1830, the term isomerism was introduced by Johannes Jacob Berzelius. In 1848, Louis Pasteur worked on tartaric acid. He has separated tiny crystals of tartaric acid into its mirror image forms. All these findings helped in understanding that chemical compounds could be different only when they have different elemental compositions. Now, let us see what are the types of isomerism. In this session, you will gain the knowledge about different kinds of isomerism. Mainly, isomerism is divided into two types. One is structural isomerism, the other one is stereoisomerism. Structural isomerism has the same molecular formula but different structural formula. Structural isomerism is divided into three types: chain isomerism, positional isomerism, functional group isomerism. Coming to the stereoisomerism, they have the same molecular formula but atoms occupy different positions in space. Stereoisomerism is divided into geometrical isomerism and optical isomerism. Geometrical isomerism occurs due to restricted rotation of carbon-carbon double bonds. Optical isomerism occurs when molecules have a chiral center. Coming to drug isomerism, where you can see how drug isomerism is related to drugs or medical field. Let me show you how drug isomerism has opened a new era of drug development. Knowledge of isomerism helps in introducing safer and more effective drug alternatives of newer as well as existing drugs. Let me explain you about this concept with few more examples. Look into the first example. Here you can see there are two structures. Structure on the left hand side is promethazine and the structure on the right hand side is promazine. You can see there is a small structural change in the side chain. This small structural change can affect the activity of the drug. Promethazine primarily acts as an antihistaminic agent and promazine acts as an antipsychotic agent. This example comes under the application of chain isomerism. In the second example, you can see a chemical compound is existing in 4 different forms. These 4 different forms have the same molecular formula, but they have different physicochemical properties. And as a result, it is possible that they have different biological activities. These 4 different isomers comes under the example of stereoisomerism. Coming to the third example, here we have 2 structures. The structure above is cetirizine, structure below is levocetirizine. Levocetirizine has less side effects compared to cetirizine. This example makes us understand that a small change in the arrangement of hydrogen atom can have effect on the drug safety profile. This example also gives us the knowledge that by making a minute change in the arrangement of atoms, an effective and safer drugs can be produced or synthesized. Thank you.